You're trying to, cut through all the noise, get right to what's important, understand the big ideas without getting bogged down. Well, you're in the right place. Welcome to the deep dive. We try to give you that shortcut to being, well, more informed.
And today, we are diving into what feels like a really fascinating new area in AI. We're going to unpack this new idea called absolute zero. It's based on a paper, Absolute Zero, Reinforced Self-Play Reasoning with Zero Data.
Absolute zero. Okay, sounds intriguing. Like starting from, well, zero. What exactly is it in simple terms?
That's pretty much it, yeah. Think about how we usually teach AI reasoning models. You've got traditional supervised learning, right, which is kind of like showing a student loads and loads of worked examples, step-by-step solutions.
Okay.
Then there's reinforcement learning with verified rewards. That's where the AI tries stuff, gets feedback like a reward if it gets it right, based on rules we set up.
Right, so in both those cases, we're still the ones guiding it, giving it the answers, or, the map.
Exactly. We're deeply involved. But what's so different about absolute zero? It just flips that whole idea. This approach trains reasoning models without using any human-made data for the reasoning part. None.
None at all.
For the reasoning, no. It's all about the AI doing what they call self-play. Imagine the AI interacting with some environment, right? And that environment can just tell it, very simply, if the result of its reasoning was correct or not. Verifiable feedback.
Huh.
It learns purely from that interaction. No human-designed tasks, no examples of how to reason provided by us.
Wow. Okay, so it's like an AI learning to think just by trying things out and getting a basic yes or no. That sounds like it could really, really shake things up, especially when you think about the limits of the current ways we do things.
That's exactly the point the paper makes. As we push for more and more advanced AI, the huge effort needed to create those massive human-curated data sets. Well, it might just become too much, a bottleneck.
Yeah, you hear about that with LLMs already, the scaling challenges.
Exactly.
Makes sense. I mean, if we want AI to really move forward, it needs to learn on its own, doesn't it? Not just, rely on us spoon-feeding it everything.
And that connects to a kind of deeper point in the paper. As AI gets smarter, maybe even better than humans at some things, relying only on human-designed tasks could actually hold it back. We might be sort of accidentally limiting its ability to learn and evolve on its own terms, putting artificial ceilings on its potential.
Ah, interesting.
Absolute Zero starts to explore ways around those kinds of limitations.
Okay, this is really starting to grab me. How does this learning by doing work, like in practice?
So the researchers built something they call the Absolute Zero Reasoner, or AZR for short. It's a specific way of using the absolute zero idea, and they focused it on teaching an AI how to code.
Okay, coding.
Now, the key part is the environment. In AZR's case, that environment is a code executor. Think of it like a super strict checker. It instantly sees if the AI's code runs correctly, gives a clear pass or fail.
Right.
So the AI proposes a coding task, writes the code it thinks will solve it, and boom, the code executor gives that immediate, verifiable feedback.
So the AI is basically setting its own homework problems.
Yeah.
And then grading its own attempts.
Pretty much, yeah. And the paper points out that AZR focuses on creating 3 specific kinds of coding tasks. This gives a structure for learning different types of reasoning.
Okay, what are they?
The first is induction. That's like inferring a general rule from specific examples. So for coding, maybe the AI sees a few examples, like input 1 and 2 gives output 3, input 4 and 5 gives output 9, and it has to figure out the rule is addition.
Okay, induction, spotting the pattern. Got it. What else?
Second is abduction. That's more about figuring out a likely cause or input when you know the program and the output. So like if the AI has a function that squares a number and it sees the output is 9, it has to work backward, abduce that the input might have been 3, or maybe make or 3.
Oh, okay. Working backward. Makes sense. And the third?
Third is deduction. That's predicting the output if you know the program, the input. It's more about just following the logical steps. If you have a function that multiplies by 2 and the input is 5, deduce that the output is going to be 10.
Right. So induction, abduction, deduction, it's training itself on these like fundamental ways of thinking, identifying patterns, figuring out causes, following logic, but all through writing and running code.
Exactly. And this is where it gets really interesting. Even though it was trained with absolutely 0 human examples for these specific coding tasks, AZR shows surprisingly strong results in math and coding.
Wait, really?
Yeah. And in some areas, it actually does better than AI models that were trained the usual way with human-generated data.
Hold on. It learned to code better in some ways without seeing any human examples for those tasks. That's kind of counterintuitive. Does the paper suggest why? Like, why learning this way without our examples could actually be better sometimes? Is it maybe avoiding our biases
Yeah.
or finding something more fundamental?
That's a really good question, and the researchers touch on that. They suggest that because AZR is generating its own tasks, potentially a really diverse set of them,
Hmm.
and getting that direct objective feedback from the code executor, it might be exploring a wider range of problem-solving approaches than if it just learned from human examples.
So it's not limited by how we think about solving those problems.
Possibly, yeah. It's maybe discovering more robust, more general ways to solve things by learning from sort of first principles through this self-play process.
Okay, this absolute zero idea really sounds like it could be huge for where AI is going. It's like it's learning the deep structure of reasoning itself from the ground up rather than just copying how humans do it. So if you had to boil it down, what are the main takeaways for someone trying to grasp where this is all heading?
I think the core takeaway is that absolute zero points to a really fundamental shift in how we might train advanced AI.
Yeah.
By, breaking free from needing human-curated data for the reasoning part, it offers a potential way around those scalability problems we talked about.
Right, the bottleneck of creating all that human data.
Exactly. Making those huge, high-quality data sets for complex reasoning takes enormous effort. This approach hints at a way to bypass that, potentially.
So we could be looking at a future where AI systems are much more self-sufficient in how they learn to reason.
That's the idea. And the strong performance of AZR, in math and particularly coding benchmarks, really highlights that potential. Getting state-of-the-art results in coding without the usual training data, that's a pretty powerful signal that this kind of self-play, this experience-driven learning, can be incredibly effective.
Well, this has definitely been eye-opening. The whole idea of AI learning to reason without us constantly feeding it examples feels revolutionary. And the AZR results certainly make you pay attention. It feels like we're getting a peek at a totally new way to think about building smart machines.
I think so. And the paper ends with this thought that really sticks with you. They suggest that AZR and maybe other approaches like it based on experience could signal a whole new era for reasoning models, an era where they're not held back by the limits of human data, potentially leading to capabilities we haven't even imagined yet.
Wow.
They actually call it the era of experience. It makes you think, right, what happens when AI can essentially define and improve its own learning process?
Definitely leaves you with a lot to chew on. It feels like we've barely scratched the surface of what this kind of AI might do.
Absolutely. This deep dive, it's just a snapshot, really. It's such a fast-moving field, and there's so many directions this could go. Lots more to explore down the road.